let's look at a couple of simple extrema examples, absolute extrema examples. This particular problem asks, at what x-coordinate, if any, does an absolute maximum occur? So we've got our function already drawn for us, so it's easy to see that the highest point in the curve occurs where x is equal to x of 1. It says, at what x-coordinate does it occur? Well, the x-coordinate is x of 1. Now, be careful because they did not ever ask. They never asked for the absolute maximum. The absolute maximum is f of x plus 1. It's the y value. But they didn't say what is the absolute maximum. It says at what x-coordinate does the absolute maximum occur. So it occurs at x of 1. They never asked what it was. Same with absolute minimum, except this arrow indicates that the curve keeps decreasing. In fact, here and here. So there is no absolute maximum. Excuse me, no absolute minimum. There is a maximum. It occurs at x of 1. And finally, the last question says, how are these answers consistent with the extreme value theorem? Now recall that the extreme value theorem says that if a function is continuous on a closed interval, it will have both an absolute maximum and an absolute minimum. So there are two basic conditions. If the function is continuous and if it's on a closed interval, then it will have an absolute max and a min. This problem did not have a min, so why does it not violate the extreme value theorem? The answer is because although the function is continuous, it's not defined on a closed interval. This arrow here indicates that the domain goes from minus infinity and on this side keeps going to positive infinity. That's an open interval. The mean and the extreme value theorem requires a closed interval. So the answer is because f is not defined on a closed interval, as the extreme value theorem requires. Which means that the extreme value theorem doesn't apply. If it doesn't apply, you don't have to have one of each. So it's that simple. The extreme value theorem requires continuity, which we have, but it also requires closed interval, which we don't have. Okay, let's look at a second example. Here we have a function, a polynomial function defined on a closed interval from 0 to 1, and we want to find the x values of the absolute max and min, and we want to find the absolute max and min. Well, the first thing to notice is this is a continuous function. It's a simple polynomial on a closed interval, so there will be a maximum and a minimum by the mean value of the extreme value theorem. But we have to find it. Now, just remember that finding absolute extrema involves also finding relative extrema, because the relative extrema are places where the absolute extrema may occur. So I want to go back to how I find relative extrema, and that involves taking the derivative. So 3 times 3 is 9, x squared minus 2 times 3 is 6x minus 3 is the derivative. Why do I need the derivative? Because the derivative tells me the slope of the tangent line. If the slope is negative on one side of a critical value and positive on the other, that tells me I have a relative minimum. If it's positive on the left and negative on the right, it tells me I have a relative maximum. So go back to your thought processes in your work with relative extrema. Then what do? You take the derivative and set it equal to 0. So you get 9x squared minus 6x minus 3 is equal to 0. And before you get too carried away, remember, if you can divide through by some number and make the number smaller, you're much better off. And I noticed that everything will divide by 3. So I end up with 3x squared minus 2x minus 1 is equal to 0. And if that quadratic happens to factor, I don't have to go to the quadratic formula. So let's give it a try. 3x and x, the only factors of 1 are 1 and 1. I want a negative 2x in the middle, so if I make the 3x negative and the 1x positive, that works. The product of two numbers is 0 only if one or the other of those numbers is 0. So that means I want to set each of those factors equal to 0. If I solve that for x, I get x equals negative 1/3. If I solve that for x, I get x equal to 1. So those are my critical values. But now remember, I'm restricted to this closed interval -1 to 0. -1/3 is in there, but 1 is not. 1 is not in the interval from -1 to 0. So I'm going to discard that interval, or that critical value, because it's not in my closed interval. So really, at this point, my absolute extrema are going to occur either at -1/3, or at -1, which is the left endpoint, or 0, which is the right endpoint. It's going to be one of those three places if it occurs. So what I would suggest is just making a little XY chart or an f of x chart and having a look. -1 is the smallest x value. The next one is -1/3, and the next one is 0. So I'm taking my two endpoints and any critical values I get, putting them in order from smallest to largest, and I want to calculate all my y values. The largest of the y values will be the absolute maximum, and the smallest of the y values will be the absolute minimum. So if I take -1 and plug it back into this function, I get 3 times -1 quantity cubed minus 3 times -1 quantity squared minus 3 times -1 plus 5. Now let's see if I can do some of this arithmetic in my head and save a little space. -1 cubed is -1, so -1 times 3 is -3. Squaring a negative is going to be positive, but it's multiplied by a negative, so it's going to end up negative. So you're going to end up with -3 minus 3, which is -6. But those two negatives make a positive 3, so you get -6 plus 3 is -3, and -3 plus 5 is 2. Now you may want to take a little more time and check that arithmetic. Now do the same thing with -1/3. Plug it in, you get 3 times the quantity -1/3 cubed minus 3 times -1/3 quantity squared minus 3 times -1/3 plus 5. Now, when you cube a negative, it's going to come out negative, and 1/3 cubed is 1/27. Now, 3 is like 3 over 1, so you get 3/27. But it's going to be negative, and I think I'll move that 0 down and take some more space here. So I get -1/27 times 3, which is -1/9. And then you're going to square a -1/3, which makes a positive 1/9, and multiply it by 3, so it'll be 3/9. But it's negative because of this sign, so it'll be -3/9. That would actually reduce, but because these are both ninths, I think I'll leave it. So I squared the -1/3 and got 1/9, and a ninth times 3 is 3/9, and that negative sign makes that negative. Then you've got a -3 times -1/3 is a positive 1 plus 5. So what you get here is 6, and then that's -4/9. You get 6 minus 4/9. 6 minus 4/9, and remember 6 is actually 54/9 minus 4/9, and after a lot of arithmetic you get 59. And now I'm ready to do the 0. That's going to be easy because everything zeroes out except for the 5. So if you're looking at the y values, when x is -1, the y value is 2. When x is -1/3, the y value is 59. And when x is 0, the y value is 5. Well, which is bigger, 2, 59, or 5? Well, obviously 2 is not bigger than 5, but 59, 9 goes into 50 over 5 times, because 9 times 5 is 45. So 59 is bigger than 5. So that means that the absolute maximum is 59, And it also says where it occurs. So 59ths at x equal negative 1/3. And then there's an absolute minimum. And that absolute minimum is the smallest number. Well, the smallest number is obviously 2. So there's an absolute minimum of 2. And it occurs at x equal -1. So they asked to find the absolute maximum and minimum. Those are these two values. And where they occur. So that's why I added the at part. And there you go.